Hello, I'm Steve Proctor. We'll talk for just a few minutes about sine bars. Sine bars are going to come in varying lengths and sizes. Here I have a much larger one built for a very special purpose, but most commonly you'll find them in increments of 5 and 10 inch are most common. They'll also come in large plates. And of course the purpose of this is to create any custom angle that you need. You can do anything from 0 to whatever you feel safe making a stack of gauge blocks on to create a custom angle for a particular inspection purpose. In this particular case, the way we'll do this is, looking at a sine bar, we're going to see a nice flat surface we're going to want to take care of. We're going to make sure that it's clean. We're going to make sure that it's free of burrs, dings, anything that's going to cause a problem with something sitting flat on it. We'll also notice is that we have 2 cylinders. These 2 cylinders are spaced a particular distance apart, and this is going to create the vertices of a triangle, which is going to help make our angle. What we're looking for here is to make sure that, of course, these are clean so that when they're sitting on a surface plate, which is where we want to take these measurements, a nice, flat, precision surface. So right now we have, sitting on a plate, level with the plate, 0 degrees. When we want to use the sine bar or a sine plate, what we're going to do is look for all the stuff we used in high school when it comes to triangles. We have a distance, and we're going to make that the hypotenuse of our triangle. And the point of this one, this particular deal, from roll center to roll center is going to be 20.62115 inches. I'm going to get that off my calibration certificate. And for most cases, you're going to look and see that you're well within tolerance. It's going to be 5, it's going to be 10, it's going to be whatever you need to get off of your paperwork in order to make the correct measurement. So you're going to find the roll center to roll center distance on your cert. You're going to use this now to figure out how to create your angle. In our particular instance, we're going to make an 11-degree angle. So to make an 11-degree angle with a sine bar, very simple process. Get to your calculator. You're going to take 11 degrees and you're going to take the sine of 11 degrees. Multiply the sine of 11 degrees by the length from roll center to roll center that we got off of our calibration cert. Multiply those together, and that's going to tell you what kind of gauge block stack you're going to make. In this case, the gauge block stack we come up with when we take the sine of 11 and multiply it by 20.62115, we come up with a gauge block stack of 3.9329. I've created that here, and we're ready to go. We're going to go to our gauge block set. We're going to build this particular stack. We're going to gently lift the sine bar, place this under the roll, and set it up. You'll notice what we've done here. Make sure we're set up stably and that it won't fall off. And you'll notice what we've done here is created a triangle. We've created a triangle with a hypotenuse of the length of our roll to roll, an x-axis leg of our gauge block stack, and because we know all of this, we know that we've now created an 11-degree angle between here and the surface plate. We can always check this out by using our protractor, and in this case, we have 11 degrees. You can do this with any combination of degrees that you need, down to the accuracy of your gauge blocks and the accuracy of your sine bar. So you can go anywhere from a simple ½ a degree all the way up to, again, whatever you feel comfortable with when it comes to stacking gauge blocks. Depending on how high you have to get, you can create these angles. So you can go all the way up, all the way down, and create a precision angle for your inspection needs. You'll find these again in bars, you'll find them in plates for larger surfaces, and you'll even sometimes find them in compounds where you can take it and go up and off to the side at the same time. Again, all depending on what your needs are, what your laboratory has, and how far you need to go. The common errors that you'll find when using a sine plate or a sine bar are going to be cleanliness, the top surface, and just kind of knowing and being familiar with your gauge blocks. Making sure your surface is clean, free of burrs, nicks, anything that'll cause any device to be off to the side or cocked at a funny angle. You want to make sure that your rolls, again, are clean, free of burrs and debris, and you want to make sure you're on a calibrated surface plate. A flat surface is integral to making these work properly. Remembering your math. Take the sine of the angle you want, multiply it by the length of your sine bar. That's your gauge block stack. Create that out of your gauge blocks, set it up. Really, it's a no muss, no fuss, and you get to use all the fun math you learned in high school. Cleaning and storage, really simple. Again, a mild cleaner. You're going to have most of these, a few special ones made of granite. You're going to use a granite cleaner on it. Most of them are going to be made of steel, stainless steel, or some other similar material. Those you can clean with alcohol, any mild cleaner. You just want to make sure that you've got all the surfaces that are going to be contacting either the surface plate or the setup that you're measuring. You want to make sure those are clean and free from debris. Any debris, any dirt is going to cause an error in the measurement. When it comes to storing them, You want to make sure if they have a storage case, use the storage case. If they don't have a storage case, find a safe, stable place to store it. High shelves are not recommended. Things fall off of high shelves. But if you can find anything that'll keep it from coming off, being a hazard to other people, being a hazard to itself if it were to fall, certainly use those.